Hello, greetings. So we have set up our profit maximizing linear programming problem for our second example on production planning from section 2.2.1 in the text. We have solved it using LibreOffice Calc. Next, I want to go through the same exercise and solve using Microsoft Excel. Okay, so let's open up Excel. So get a new blank workbook. Okay. And again, as I set up my Excel sheet, I'm going to try and keep things as general as possible, just to make it easier on me if I want to go back and do some sensitivity analyses, or see what the effect of variables are playing, or parameters playing what if scenarios. So let's do this. Okay. Um, so we'll have three products 1, 2, and 3. I'll need to know what the profit is in dollars per product, and then what we need to know what the how many units of each product we have. So looking at the problem, so the profits of the products are 18, 12, and $6. So that's 18, 12, and $6, and that's per unit. So then in terms of number of units, I need to start with an initial guess for my solution. So I'm just going to type 1, 2, and 3 in there for now. We'll come back to this because I'm pretty sure we have a constraint that we need to have at least 2 units of product 2. But next I'm going to define my objective, which is my total profit in dollars. Okay, this is the quantity that I want to maximize. And so my total profit will be equal to the profit in terms of dollars per product of each product times the number of units of each product. And again, this is a formula cell, so I begin with an equal sign. Okay, so then I do the same for component 2, and the same for component 3. Okay, next I need to think about my constraints. Okay, and the constraint we'll have here in this problem has to deal with the total capacities of our machines. Okay, so I'm going to start by essentially reproducing this table. Okay, now remember this table below tells us how many units of the product can be made each hour. So this says units per hour. Okay, units per hour. And I emphasize that because we'll need to flip it. We need to get it to units per hour. And so we're going to have to flip it to hours per product. So when we multiply by the number of products, number of units of each product made, we can calculate the total time required to make those products. Okay, so I'm going to reproduce this table. So have machine 1 and machine 2. Okay, and we have P1, and this is product per hour. Okay, P2 and product. So I guess it'd be technically like units per hour. Product 3. This is in products per hour. Okay. So 3, 5, 10. 6, 4, 12. Okay. And then I also want to get the total capacity of our machines, which are 24 and 16. Oh, that's an hour. 24 and 16. Cool. So then think about, call it constraint M1. So the constraint on machine 1 is what I next need to calculate is if I were to make, X1 units of product 1, X2 units of product 2, X3 units of product 3, what's the total time required to make those on machine 1 and machine 2? Okay. And then my constraint is going to be that total time on machine 1 and machine 2 has to be less than or equal to the total capacity of that machine. Okay. And so 24 and 16. Just notice I had 6 here. Okay. So to calculate that then, it's going to be equal to the number of units of each product type and then it's going to be divided by this rate here. Okay. Remember, this rate is in products per hour. I want to divide by it. So essentially 1 over this rate gives me units of hours per product, right? How many hours are required to make a product. So while here I can make 3 products per hour, that'd be the same as requiring 1/3 of an hour per unit product. Okay. So I want the inverse so that when I multiply it by the number of units of each product, it gives me how much time is required to make that product. Okay. So it'll be plus number of units of product 2 divided by the rate for product 2, or divided by the rate for product 2, plus same thing for product 3. Bam. Okay, I'll get M2. So for machine 2, it's going to be the same thing. Number of units of each product type divided by the rate for machine 2. And then I sum those all up. Okay. So this gives me total production time in hours to make those units. And then, a note is, so here's our, time capacities. So if I wanted to, if I were to, looking at this first expression, I could subtract 24 from each side of the equation. So essentially bring 24 over here. And what that would do is my comparison then would just be to 0. The right-hand side would just be 0. If I were to make all my logical operators, a comparison to a common value, I could do that. It's just a matter of preference. I won't do that here, just so we can see that case. Then the last constraint we'll have is that we're told that we need to have at least 10 units of the second product. And so let me just call this constraint x2. All right, we need to have at least 10 of them. And I'll hard code this one just in case we want to play some of these what if scenarios later on. All right, so from there, I'm going to go to data, then solver. Okay, and my objective is to maximize my profits. Bam. By changing cells. Okay, these are my variable names. Okay, I'm going to take a step back because I just said that I need to have at least 10 units of product 2. So let me go ahead and change that to 2 or 10 before we solve. Okay, so I'm going to maximize that. I'm going to change the number of units of product 1, 2, and 3. And I'm going to use my simplex solver. Okay. Now there is a checkbox that I'm going to make unconstrained variables non-negative. And so that means that x1, x2, and x3 would need to be greater than or equal to 0. So that's great that it's checked. If you want to uncheck it, you could just hard code and manually state that. Okay. But in terms of constraints, I'm going to have that the total production time on machine, or required production time on machine 1, needs to be less than or equal to the capacity of machine 1. I'm going to have that the total production time of machine 2 has to be less than or equal to the total capacity of machine 2. I'm going to have that I need at least 10 units of product 2. So I'm going to have x2, number of units of product 2, has to be greater than or equal to 10. Okay, and I could just bring that over to the left-hand side or play around with that if I wanted to make everything common to common right-hand side of 0. Okay, and so that would be fine with this non-negative checkbox fixed. If I wanted to uncheck this, then I would just add that x1 and x3 need to be greater than 0. Okay, but leaving that unchecked, we can solve. Okay. Says that it found our answer, and that's what we get. So we get, let's see, 43.5, 10 units of product 2 and 75 units of product 3 for a profit of $1,353. Right? So solving, we're able to get the correct answer. Okay. So there you have it. We just solved the problem in Excel. And again, part of the fun of Excel and generalizing it like this is that you play what if scenarios. So if I go back, what if I were to double all of the profits, right? What would happen, right? What if my profits were double? Okay, so what if this were 12? This would be 24, and this would be 36. Okay, so if I just doubled it, I would expect everything to remain the same. Okay, and I solve, and the number of products that it would make are exactly the same, right? It doesn't change anything. It just increases my total profit. So if I change this back, okay, what if though the third product increased in value to $20? So if that increased to $20, and I were to solve, all right, now the distribution is much different, all right? It's pretty much you just want to make product 3, make the bare minimum of product 2 in product 1. Okay, but there you have it. Hopefully that helps. Let me know if you have any questions.